Hi, in this video we are going to work on the laws of logarithms. Logarithms. Now that the logarithms are related to indices, we could convert the laws of indices to laws of logarithms. So basically we have three laws like multiplication law, division law, and the power law, right, in indices. So it's similar in logarithms. So we're going to convert the notation and use these properties, the laws, in logarithms. Let's see how we convert the multiplication law. So let's say log the base a to the x is m, and log in base a of y is n. Now this makes x equals a to the power of m and y equals a to the power of n. So this is by definition, right? And then let's multiply x and y. So it's going to be xy equals a to the power of m multiplied by a to the power of n, which will give us, if we use the multiplication law of indices, a to the power of m plus n. So if I have xy equals a to the power of m plus n, then I can convert this back to logarithms notation and write down logarithms in base a of xy equals m plus n. Now notice that I write the base here, I write the power here, and this product must be in here. So I have log in base a of x times y equals m plus n. Now what is m plus n? Well, m plus n is these two logs, right? So I can write, instead of m plus n, log in base a of x plus log in base a of y. So this is equal to this expression. So basically I can write log in base a of x times y would be log in base a of x plus log in base a of y. Now this is a very important law, but at the same time we make a lot of mistakes in here, getting confused with the addition. We sometimes consider log in base a of x plus y equals to this. So this is very important here, that we shouldn't make this mistake. Now let's see an example. Now in the first example we have log in base 5 of 8 and log in base 5 of 7 in addition. So basically that's going to be log in base 5 of 8 times 7, which is log in base 5 of 56. So yeah, you don't need to write this step. You can end up with this expression immediately. And for this one, you could either write log in base 8 of 3 times 8 and say this is log in base 8 of 3 plus log in base 8 of 8. Or if you'd like, you could write log in base 8 of 6 times 4, which means log in base 8 of 6 plus log in base 8 of 4, right? So according to the factors you end up in here, you can just fill in the numbers here. So as you can see, this equation works in both ways. You can write a product here as a sum, or you can have a sum of two logarithmic expressions and you can write them as a single logarithm, right? And you can have the product here. Now the second law is the division law. As you can guess, we're going to divide two numbers. So let's assume log in base a of x is m and log in base a of y is n. And here, by definition, I can write a to the power of m equals x, and then a to the power of n equals y. Now, if I compare x and y, if I write a fraction, then I can also write down a to the power of m over a to the power of n. But by index laws, I know that this can be written as a single index number, which would be a to the power of m minus n. Now, if I convert this to a logarithmic expression, then it's going to be log in base a, right, of this expression, x over y, so it's the division of these two, right, equals the power m minus n. But then this logarithmic expression is nothing but, if I write m and n, the values in logs, it will be like logarithms of x in base a minus logarithms of y in base a, right? So if it's division, then you take away those logs. So for example, if you have log base 5 of 8 minus log in base 5 of 4, then you can write this as log in base 5 of 8 over 4, which will be log in base 5 of 2, right? So this is how you can use this identity. Now, it works in both ways. Again, you can write a single logarithms here, or you can have a fraction which you can also write as two separate logarithms in subtraction. Now the last one is the power rule. So what happens here is, if we consider a logarithmic expression like log in base a of x being equal to m, and instead of this, now we're going to have the kth power of x here, alright? And from here we can convert this to an index number. We can say a to the power of m equals x to the power of k. Now, if you take the kth root of both sides, you will end up with x equal to a to the power of m over k, right? This is how we can convert a surd or a root into index number, so m over k. Now this means I can write the logarithms in base a of x being m over k. So the power goes here, right? The base goes here, and x goes here. So it's log in base a of x equals m over k. Multiplying both sides by k, right, I end up with k times logarithms in base a of x being m. Now, what is m? M is this expression. So I can write logarithms of a in base a of x to the power of k, which is m here, right, equals to this expression, k times logarithms in base a of x. So this is how we use the power rule. So if you have a power here, you can just write it as a product or as a coefficient in front of the logarithmic expression. Let's see an example. I can write this expression as 3 times log in base 4 of 7, right? Or if I have log in base 5 of x cubed, right? I can write this as 3 times log in base 5 of x. Now, applying the laws does not matter much on its own. The problem is you have to be converting or simplifying logarithms expressions by using a combination of these laws. Let me give you an example. Write in terms of log x, log y, and log z. So we have this expression log in brackets x squared yz cubed. Now these three unknowns with powers are multiplied. So first of all, I can write this as log x squared plus log y plus log z cubed. Now the question requires us to write them in terms of log x, log y, and log z only. So there are no powers around, so this is not enough. I will go on and simplify the first and the third log. So it's going to be 2 log x plus log y plus 3 log z. So this is the simplest form, or this is the way I can write this logarithmic expression as in terms of log x, log y, and log z. Another example. So log x times root y of z, basically this is going to be log x plus log root y minus log z. Now the problem is with the square root y here. We know that the square root means 1/2 as a power, so that's going to be equal to log x plus 1/2 times log y, because here we said root y is y to the 1/2, right? And 1/2 comes in the front, and we go on with log z as subtraction because it's division over there. Now, before we close, let's talk about special cases. Now, the first one is obvious. In any base of logs, right? Log in base a of the base itself, so log in base a of a is always 1. Why? Because we know that any number to the power of 1 gives us the number itself, right? So that is why we end up with 1 when we have the same number appearing here as the base. So if these are the same, you end up with 1. Next, again, regardless of the base, if you have 1 appearing here, then you end up with 0, because a to the power of 0 is 1 for every a but 0, right? Because if a is 0, then you end up with 0 to the power of 0. This sounds as if it is okay, right? But it is not, because any number to the power of 0 is 1. So we have to say that 0 to the power of 0 is 1 as well. But, well, it doesn't make sense because it's 0 we are talking about. So basically, this expression is undefined. So we don't let that a value to be 0. And next, and the last one, it's going to be in any base of 1 over x, alright? Now, if we apply the division rule here, we're going to end up with log in base a of 1 minus log in base a of x, right? Because it's division, we have subtraction here. And now that we know, because of a to the power of 0 is 1 for every a, which is non-zero, now that we know that this logarithm is 0, so I end up with 0 minus logarithms of in base a of x, which means minus log in base a of x. You can also go like rewriting the log here as logarithms in base a of x to the power of -1, right? And then you can have the power appear as a coefficient here, so it's -1 times logarithms of x in base a, so you basically end up with minus log in base a of x, so it's the same thing. So there are two ways of proving that logarithms in base a of 1 over x is minus logarithms in base a of x. So basically, we have 3 laws and 3 special cases, which we have to know because they won't appear in the formula sheet, right? So these are the laws and special cases you will be using to simplify logarithms, logarithmic expressions, and also to solve logarithmic equations. One final thing before we finish, it is very important to write the logarithms properly. So if this is your line, you should be writing log in base a of x to the power of k as like this. So this is superscript, which is above the line, yeah? So this is your base here, x to the power of k, right? So this is superscript, and this is subscript. It must be below the line. Now it's important because sometimes we see students writing down all of these all together, a, x, and k, like that. So it get mixed up. Or you write them as logarithms of a, x, and k. So that also is a confusion. So make sure that you're writing the logarithms properly. Thanks for watching.